In this lesson, we're going to take a look at compound interest and how we use our compound interest to solve for values other than the final amount. So we're going to look at an example where we're solving for the principal, one where we're solving for the number of years or the number of times we're earning interest, and one where we're solving for the actual interest rate. So our first question here says Odette invests some money in a high interest savings account that earns 9.2% per annum compounded daily. She has $2,416.36 4 years later. How much did she originally invest? And how much interest did she earn? Now, when it asks how much interest did she earn, it's not asking about the interest rate, which would be the 2.92%. It's asking about, in dollars, how much interest did they actually earn. So I'm just going to underline all the things that I think are important. So I do see that there's an interest rate of 2.92%, and that is being compounded daily. She has $2,416.36, and that's going to be 4 years later. And I want to know how much did she originally invest, which would be my principal. So the first thing I need to do is figure out whether I think this is simple or compound interest. And since I do see the word compounded sort of off the screen there, that does tell me that we should be using our compound interest formula. Now our compound interest formula is the formula A equals P times 1 plus I to the power of N. A is our final amount. P is our starting amount, otherwise called the principal. That's just a 1. I is the interest rate as a decimal, so we divide it by 100 to make it a decimal. And the N is the number of times that we're earning interest. So I like to list my formulas or my values down the side. I always leave a little space for the I, since I know we usually have to do some calculation here. So the 2.9% is my interest rate. So I'm going to put that in. So the 2.92%. Now, it says that it's being compounded daily. So we don't earn the full 2.92% 365 times. What happens is the bank splits that up into 365 equal pieces. So we're going to divide this into 365 pieces. And then to turn it into a decimal from a percent, we also need to divide by 100. So I'm going to do that on my calculator. So 2.92 divided by 365 divided by 100 is 0.00008. Okay. It says that we have $2,416.36 4 years later. So that's not the amount of money they're putting in at the start. That's how much money Odette has at the end. So that's going to be my final amount. And it says it's 4 years later. So for our N, I'm going to say that it's 4 years. But she's not earning her interest only 4 times. She actually earns her interest every single day for 4 years. So we know in a year we have 365 days. So I do 365 times 4, which is 1,460. Now, if we wanted to be a little bit more correct, we could add in 1 extra day, because if there are 4 years, one of those should be a leap year. But I am just going to ignore the leap years and leave it as 1,460. So we're going to take our formula and substitute in all the things we want and what we know. So I don't know what my principal is. That's the starting amount. That's what the question's asking us for. So I'm going to substitute in all the other numbers. So I get 2,416.36 equals P, which I don't know, times 1 plus I, which is 0.00008. You always want to make sure you count the zeros, to the power of 1,460. Now, I could work this out, get a decimal, but if you do that, you have to make sure you write the entire decimal down and don't round anything. What I prefer to do is do it in one step on my calculator. So I do see that I want to solve for P. And I ask myself, what's going on right now between the P and all of this stuff? And the answer is we're multiplying. So to take this to the other side, I am going to divide both sides by 1 plus 0.00008, or that would be 1.00008 to the power of 1,460. So on my calculator, and I'm going to do 2,416.36 divided by 1.00008 to the power of 1,460. So 2,416.36 divided by, now I could put the bracket in, it doesn't really matter in this case, 1.00008 close bracket to the power of 1,460 equals, ta-da, $2,149, and it looks like 99 cents, except the next number is an 8, so it's going to push that up, which pushes that up, which pushes that up, which pushes that up to $2,150. Okay, so that's the first part of the question. She originally invested, so Odette invested $2,150. Now, one way to check to see if we're in the right ballpark here is that it should be less money than she finished with. So if you end up getting that she invested more money than what she ended with, that's not a good sign. And I also notice it's not a huge difference. It's about $300 or less. So I feel like that's a reasonable amount of interest for her to have earned. Now, the second part of the question says, how much interest did she earn? So she put in $2,150, and she got out $2,416.36. So I'm going to take my $2,416.36, which was the final amount. I'm going to subtract how much money she put in out of her pocket, which is the $2,150, and I end up with 2,416.36 divided by, subtract 2,150 gives me a difference of $266.36. So she earned $266.36 in interest. Okay, our next question we have says Milo invests $500 in a savings bond that earns 2.4% per annum compounded semi-annually. When he cashes the bond, when it cashes the bond in, it is worth $605.14. How long was the money invested for? So first thing I'm going to do is underline all the important things. So he's putting $500 in. We're getting 2.4% per annum. It's being compounded semi-annually, which is 2 times a year. When he cashes it in, it's worth $605.14. And what I want to know is how long was the money invested for, which is my N. So when I take a look at this question, I do see that it is compounded, which means this is a compound interest question. So I'm going to write down my letters A, P, I, and N. And I'm going to use the formula A equals P times 1 plus I to the power of N. That's my compound interest formula, as opposed to simple interest. Now for the $500, that $500 is his initial investment. So that's the principal, the P. The 2.4% per annum is the interest rate, but it's being compounded semi-annually, which is twice a year. So the bank divides that into 2 equal installments, and then we also divide by 100 to turn it into a decimal. So 2.4 divided by 2 divided by 100 should be 0.012. Now, the $605.14, that's our final amount. And what I'm missing here is my N. So I don't know how many years we invested it for or how long we invested it for, but I do know that if we were investing for, say, 10 years, then we'd actually get interest 20 times because we always earn our interest twice because it's semi-annually. So whatever this number is, I am going to have to multiply it by 2. So that's going to come in handy later. So because it's semi-annual and we're doing it twice a year, that means you would take the number of years and times it by 2. So I'm going to take these numbers and substitute them in. So I have 605.14 equals P, so that's 500, times 1 plus I, which is the 0.012, to the power of N. I'm going to leave off the 2. You could put 2N in there if you like. It might actually make it easier for you in the end. So from here, I want to solve for N this time. So I cannot multiply these together because order of operations says you have to do your exponents first. So I can't touch this until I've dealt with the exponent. So I am going to start by taking that $500 to the other side and dividing. So $605.14. If I divide that by 500, I get a decimal, and you need to make sure you keep every single last decimal place. Do not round. So 1.21028. And then since this is inside the bracket, I can at least add that together. So I get 1.012 to the power of n. Now to solve an equation where we have an exponent of n, and that's what you're trying to solve for, you want to try to write these as powers of the same base. And we've done that before, but normally the base is a little bit nicer, like 2 to the power of something or 5 to the power of something. So what I need to do is find 1.02 to the power of what gives me that number there. So I want to try to write that as a power of 1.012. Now there's 2 ways to do this. Okay, one is guess and check. So try guessing a number and then pick higher or lower depending on whether you get closer. So I could say, what about to the 10? So I could do 1.012 to the power of 10. And that obviously is a little bit too small because it's 1.12 and I need it to be 1.21. So I could go a little bit bigger. I could try 15. So 1.012 to the power of 15. And if I take a look, that's a little bit closer. And then just keep going until you find something that works. Your other choice is you can take this number, so 1.21028, and you can divide by 1.012. Now this kind of calculator works really well because if I hit equals, it just keeps dividing over and over and over again. So if I hit equals, what I want to do is keep going until I get a 1. So I'm going to divide 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Oh, went too far. So I'm just multiplying by 1.012 to go back. So that was, I think, 16. Got me really, really, really close to a 1. So you want to get as close to 1 as you possibly can. So I'm just going to check there. So 1.012 to the power of 16 comes pretty close, right? So I've got 21028, and there's some extra decimal places there, but because this answer probably was rounded, that's why it's not going to be exactly perfect. So you can guess and check until you find something. You can try the divide method until you find something, but either way that is, a 16 gets me pretty darn close. So since the bases are the same, then the exponents are the same. So 16 equals n. Now that doesn't mean that it took 16 years. That means that it took 16 quarters. So here, that would equal 16. So what you have to do is say, okay, well, what did I multiply by 2 to get 16? I multiplied 8 by 2 to get 16. So you have to take into account the fact that we multiplied by 2 to get this number. So that means the money was invested for 8 years.